Hey everyone, just a quick review of the discussion that we took on Friday afternoon. The first thing I want to just recap is inside my magnifying glass here, where we talked about inscribed angles, central angles, and an arc. Now, the central angle is the angle that's in the middle of the circle, and that's where point A goes to O and B goes to O. When we put those together, that creates the central angle, and it's within the central arc. Now, any angle that is created off the same 2 points of A and B, and it touches the outside edge of the circle within that arc is called an inscribed angle. Down here, we have the measure of a central angle is twice the measure of an inscribed angle subtended by the same arc. So that means in this diagram right here, we have angle AOC, which is 2 times the measurement of angle ABC, which is right here. All right. Uh, Once we have that all on there, it talks about the inscribed angles property. So inscribed angles subtended by the same arc are all equal, right? So in this diagram right here, we have arc AB, which is represented by the darker line. Any angle that's inside that, the inscribed angles, not the central angle. There's no central angle in this diagram, so these are all inscribed angles. They all have the same measurement. Okay, moving forward. So when we're using our inscribed angles, as this says, this is find the values of angle X and angle Y. Well, there's our arc AB, and there's one measurement right there. From that one measurement, we'll be able to figure out what the degrees is for Y and what the degrees is for what X. So basically, in between angle or arc AB, this inscribed angle is 22 degrees, therefore Y is going to be 22 degrees. Now the central angle is twice the measurement of this one. So this is just 22 times 2, and we'll get the 44 degrees as represented in the example down here. And because these angles are all inscribed, they all have the same measurement. Last thing we didn't really get to talk about from our discussion on Friday was talking about angles in a semicircle property. Now, a semicircle in this case here is from point A right there all the way to point B right there. So it creates a semicircle or half a circle. Now, according to the property, inscribed angles subtended by a semicircle are right angles. So all of those angles right there, angle AFB, AGB, and AHB, all have a measurement of 90 degrees. When we use this rule or property in an example to find X degrees and Y degrees in this case, the X degrees is pretty straightforward, which is right here because this is the semicircle MN. There's the M, there's the N, and it creates a semicircle. They give us one measurement. Angle N is 40 degrees. X is going to be 90 degrees according to our property, our semicircle property. Once we have those, it's pretty straightforward to figure out what Y is. We just use our angle sum property, just like that, and we move forward. All right. That is pretty well the last part of our math discussion. Please view this video, and the assignment will be posted post haste.